Here's an old Gus Pro Blademaster skate holder, sharpen skates with. This is the pad that goes against the machine surface. You got a blade in here, you go back and forth. Got the wheel on here. Clamp on here. Got two machine surfaces. These are lifted up and down from the reference surface by these arms. So this arm is down, it brings this edge down. Move this down, it moves this edge. So it's between here to here is what it's adjusting. So it's adjusting the black plate. You zoom in here, you can see this plate's moving with respect to this. So it's got a cam. That's an eccentric in here. Eccentric here, an eccentric here, and it revolves around. What these are for, these are done at the factory so that on your unit you get to where nominally for an average blade that you're using, 3 millimeters in hockey say, it's at the center of the wheel here, like this. So you can have the blade like this, or you can have it like this. You want to completely have this thing to where it's hitting the bulge on the grindstone. This is curved this way. That's the radius of curvature, radius of hollow. So on this type of holder, this extrusion here is all the same up to this. The sliding piece is actually the black piece is what is moving. So the course adjustment they do at the factory to get the ears, so at the 3 o'clock and 9 o'clock position in the middle, they go through and back this off. And that lifts up a plate that's in here, lifts up this bar piece. And so these here are what lift this up. So normally you don't fiddle with these. So to get this here, this is going to bear against this piece here and push it up, which is the cradle that holds the eccentric. So when you're going up and down here, this piece, cradle here, the fork piece here, is not moving. So this is an eccentric. So if you look right here, and I put a mark, go all the way down and put a mark, I go all the way up, it's moved just a little bit. So if you get one of these things used, you can get where somebody doesn't know what they're doing, they'll go through and fiddle with this thing. You can have it to where when it's where it needs to be, it can be that one of these is way down, one of these is straight, because somebody, Kilroy, got in here and they jacked with this thing and they got this thing screwed up. So that's kind of what happens sometimes. So just because one of these is down and this is straight, it can be this guy's right on the money from the Z-axis up on both sides. And these unscrew here so that you can hide them so you don't have somebody fiddling with this thing. And sometimes that's a wise thing to do, so you don't have somebody, if you got a bunch of blades that are all consistent, you don't want somebody messing with that. So again, these are just the adjustments here for the eccentric. And when they're used, a lot of times you got to be careful, because it can be somebody's got in there and they fiddle with the thing and don't understand the geometry. You can get them to where these are nicked here, where they've gone through and kissed the stone. You can get to where this is all ground down. A lot of times on a skate holder, one of these is missing the clamp. You see them sometimes used on eBay. They'll have missing the clamp, they're missing this piece. Of course, this goes on like this, or it can go on like this. Generally, all these different brands have a slightly different Z height. So you can't just take one of these and use it on an easy sharp machine or a Blackstone. They kind of vary about, probably, if you took all the ones ever made in the last 60 years, they probably vary Z height more than almost an inch. A lot of them are fairly close, but you can't just assume that a Blademaster is going to fit on an easy sharp machine. Easy sharp has two different Z heights because they've changed that about 20 years ago. The red models, they got a little bit higher Z height. And generally, they've gone higher Z heights because some of the skates today tend to be, the molded skates tend to be fatter. And so, on some of the machines that have the three knobs on them, there's like a Trilite one, you can lift this up and tilt it. And that's a little bit more involved. You can adjust a little bit more, but you can have a blunder where part of the skate actually is touching one of the knobs. So it's kicked up like this. So you got to make sure that when your skate's in your holder, you don't have any blunder where this is touching something down here. You don't have to go crazy clamping these things. It can be snug, but some people tighten it so tight you'll end up busting the this piece, warping it. And there's different plates on these they've made over the years. Some for figure skates. A figure skate's got a 4mm blade versus a 3 for generally for hockey. And so a lot of the old goalie skates were 4mm. So the Z height on this is set lower. So one of these is set up for, this is right on the money. For hockey skates, you have to go way lower on figure skates because the center is different. So if you took the grind disc like this and you put this on here for a hockey skate, and this is the reference surface here. Let me look down here like this. This is the reference surface on the holder. This is the disc. If this is a 3mm hockey blade here, you put a 4mm blade on for figures, it's like this. So this, where the whole, you can't lift the disc up by 1/2 millimeter. So when you go 4 minus 3 is 1 millimeter. You got a 1/2 millimeter difference. So this edge on a holder has got to be 1/2 millimeter lower for figure skates generally. So it's good to have a micrometer to measure what you're going on here with this. So most of the time people have one fixture for figures and one for hockey, so you don't mess around and have to. A lot of the machines do not have the range of motion here. May not be a 1/2 millimeter, may or may not.